So basic concepts in probability, conditional probability. We consider a distribution over a population of students taking a certain course. The space of outcomes is simply the set of students in the population. Now suppose that we want to reason about the students' intelligence and their final grade. So we say that event A is all students with grade A and event beta is all students with high intelligence. Using our distribution, we can consider the probability of these events as well as the probability of A intersection alpha. So A intersection beta means the people or the students who are having grade A as well as they are intelligent. So the set of students who are intelligent who got a grade A. This, however, does not directly tell us how to update our beliefs given new evidence. Suppose we learn that a student has received the grade A. What does that tell us about her intelligence? This kind of question arises every time we want to use distributions to reason about the real world. More precisely, after learning that an event A is true, that means all students have got the grade A, how do we change our probability about beta occurring? That is, all students with high intelligence. The answer is by the notion of conditional probability. So, conditional probability defined as the likelihood of an event or outcome occurring based on the occurrence of a previous event or outcome. So, likelihood of an event or outcome occurring, likelihood of a person being intelligent based on the occurrence of a previous event or outcome. That means based on whether that student has got a grade A. So if the student has got a grade A, that means the student is an intelligent student. So likelihood of an event of intelligence occurring based on the previous occurrence of grade A. Conditional probability can be contrasted with unconditional probability. Contrast means it is the opposite of unconditional probability. Unconditional probability refers to the likelihood that an event will take place irrespective of whether any other event have taken place or any other conditions are present. That means the event intelligence will take place irrespective. So event intelligence will take place irrespective of grade A is nothing but your unconditional event. But what are we talking about? We are talking about conditional events where intelligence is dependent on grade A. If the student has got grade A, then only the student is an intelligent student. But what is unconditional probability? That the event is not dependent on a prior event. So key takeaways. Conditional probability refers to the chances that some outcomes occur given that another event has also occurred. It is often stated as the probability of B given A and is written as probability of B given A, where the probability of B depends on that of A happening. So probability of B means probability of being intelligent, student being intelligent depends on A occurring, that is student getting a grade A. So probability of B will depend on the A probability. Conditional probability is contrast, is opposite of unconditional probability. So this is very important slide, that is definition of conditional probability. The conditional probability of alpha given beta is the probability that the event alpha will occur given that another event beta has occurred. So probability of alpha given beta is the probability of an event alpha will occur given that beta has already occurred. So this is your formula, that is probability of alpha given beta is equal to probability of alpha intersection beta upon probability of beta, where your probability of beta should not be equal to 0. If it is equal to 0, then you cannot solve it, right? So it should not be equal to 0. The denominator should not be equal to 0. What is the denominator? The denominator is probability of beta. That is the probability of event which has already occurred. Now conditional probability, this is your sample space. Suppose there are 100, A is 50, B is 50, this is 20. So probability of A given B is probability of A intersection B, that is 20, upon probability of B, that is 50. Your answer will be 2 by 5 is the probability of A given B. So the common elements of A and B are suppose 20. So A intersection B means the common elements between A and B upon the probability of B. Now, if the outcomes of an experiment are equally likely, then probability of A given B, that means probability of A occurring given that B has already occurred, is equal to number of outcomes in A intersection B upon number of outcomes in B. This is a formula. So this is also an important formula. Even this is also a formula which is important. Conditional probability formula. Probability of B given A, probability of B occurring given that A has already occurred, is equal to probability of A and B upon probability of A, or probability of B given A is equal to probability of A intersection B upon probability of A. So this is the formulas of conditional probability. Next is your chain rule. Probability of A given B, you know that the formula is probability of A intersection B upon the probability of B, that is the event has already occurred. Conditional probability can be written as follows. Probability of A intersection B will be equal to probability of A given B multiplied by probability of B, known as the chain rule of conditional probabilities. Similarly, if alpha 1 till alpha k are the events, then we can write probability of alpha 1 intersection alpha k is equal to probability of alpha 1 into probability of alpha 2 given alpha a till probability of alpha k given alpha 1 intersection till alpha k minus 1. So this is also your formula of chain ruler. This is also the formula for chain ruler. Conditional probability. What is conditional probability? It is defined as the likelihood of an event or outcome occurring based on the occurrence of a previous event or outcome, calculated by multiplying the probability of the preceding event by the updated probability of the succeeding event on conditional event. So what is the likelihood of an event or outcome to occur given that already there is a previous event which has occurred? So for example, let us see one example of some problem there is. So it says event A is that an individual applying for the college will be accepted. There are 80% chances that the individual will be accepted. So 80% means 0.80. Now event B is that an individual will be given dormitory housing. Dormitory housing will be only provided to 0.60% of the people who are accepted. So we need to find what? Accepted and dormitory housing. So basically we need to find this, that the people who are accepted and they have the dormitory. So we have to find this, that P is accepted and dormitory is equal to P of B given A into P of A. So this formula we need to apply. So P of accepted as well as A, that person has dormitory, is equal to P of B given A into P of A. So accepted and has dormitory is equal to P of dormitory occurrence, that it would be given the dormitory housing. It will depend on what? It will depend on whether the student is accepted or not. So dormitory housing given accepted into P of accepted. So that is 0.60, that is this, into 0.80, you get 0.48. So this was an example. Now next part is your independent events. So we have studied about, till now we studied about the events which were conditional probability, that means events which were dependent. If B was occurring, occurrence of B was dependent on the occurrence of A. So we say that they were conditional events. Now we learn about the independent events. If the probability of occurrence of event A is the same regardless of whether or not an outcome B occurs, then the outcome A and B are said to be independent of one another. Symbolically, you represent it as P, A given B is equal to P of A. Then A and B are independent events. That means whether or not B has occurred or no, A will occur. So which is equal to probability of A. It does not depend on occurrence of B. Now, independent events, P of A intersection B is equal to P of A given B into P of B. If this is there, then we can state that for independent events, P of A intersection B is equal to P of A into P of B. So this is the formula for independent events. Independent events. So let's see an example. A coin is tossed and a single six-sided die is rolled up. Find the probability of getting a head on a coin and a 3 on a die. So a coin is tossed. In coin you have two heads also and tails also. So tail and heads are there. They are saying that it is tossed and you get a head. So P of A will be head. How many times you can get a head? One time. Total possible outcomes are 2. And a coin is tossed. For coin, 1 can come, 2 can come, 3 can come, 4 can come, 5 can come, even 6 can come. So there are 6 possible outcomes for a coin, out of which 3 has come. So P of B is equal to 1 times 3 is present in this. How many possible outcomes are there? 6. Now we saw the formula of P. A intersection B is P of A into P of B. So we'll write here P of A intersection B is equal to P of A into P of B. P of head and 3 is equal to P of A is 1 by 2 into P of B is 1 by 6, that is 1 by 12. So for independent events, formula is P of A intersection B is equal to P of A into P of B. For your conditional events, formula is P of A intersection B is equal to P of A given B into P of A. A given B into P of B. This was the formula. Okay. So why is this P given B? Because this B is A is dependent on B. So B will come in the denominator. So we write that B, we multiply that B in the numerator. And for A intersection B, we have P of A into P of B. Independence formula for three events. Example, if E, F and G are independent, then P of E intersection F intersection G is equal to P of E into P of F into P of G. So this is also an important formula for independent events where there are three events. For two events, if there were only two events, say A and B, we said it is P of A into P of B. When there are three events, we say it is P of E into P of F into P of G. Suppose if E, F and G are independent. The notion of independence applied to conditional probability. If E, F and G are independent given that an event H has occurred, then we say that P of E intersection F intersection G given that H has already occurred is equal to P of E given H has occurred into P of F given H has occurred into P of G given that H event has occurred. So this is also one more new formula that the event has already occurred. So for independent event, there is no need of an event to occur actually. But when you are said in the question that an event H has already occurred, E, F and G are independent events, but an event H has already occurred, calculate the probability. We use the formula of P of E intersection F intersection G given that H has already occurred because E, F and G were independent events equal to P of E given H into P of F given H into P of G given H. Independent events versus mutually exclusive events. If two events are independent, P of A given B is equal to P of A and P of A intersection B is equal to P of A into P of B. If two events are mutually exclusive, they do not share a common outcomes.